Okay, we're going to solve the second problem here from the rates of change in tangent lines problem set. So this second problem is about the population in hundreds of fish in a pond. Is this this function that involves a linear component 2t and also a trigonometric component sine of 2t minus 10. Time is given in years, and the output is the population of fish in hundreds. Okay, so first thing we need to do when you do this problem set is you actually evaluate all of these values of x to find the average rate of change. And in the similar to the previous problem, we're looking at getting closer and closer to 5, both from the left and from the right when x equals 5. So I'm not going to calculate all of these, but we'll do a sample: 5.5, 5.0001, 4.5, and 4.9999. Okay, so the average rate of change is the secant line. Or I should say the slope of the secant line. So that's p of t minus p of a divided by t minus a. So for 5.5, when time equals 5.5, you are going to figure out the average rate of change, average rate of change, ARC, or you can use some other abbreviation. It's going to be 2 times 5 minus the sine of 2 times 5 minus 10 minus, so that's p of t when time is 5, minus 2 times 5.5 minus the sine of, I'll run out of real estate here, 2 times 5.5 minus 10. So again, evaluating the function. Dividing that by 5 minus 5.5. So maybe a little bit more succinct way to write that is evaluate the function at 5, evaluate the function at 5.5, take the difference, and then subtract the x values. When you do that, you get something like 3.68, something like that, and it kind of goes on. They ask for 8 places. We'll just go with that for now. And get another piece of paper here to do the second part, or the other parts. So now I want to look at 5.0001. So this is Roman numeral 5. And you put that in your little handy-dandy calculator, and you get 3.98669,331. So I actually carried that one out to the 4 decimal places. Oh, you know what? Misreading my notes there. I had a whole bunch of these calculated. Oh, you know, I actually did this in my calculator, and it gave me 4. So I think it's starting to get to the point where the calculator can't even estimate because these numbers are getting closer and closer. Let's look and see what happens when you do Roman numeral 6. Now, Roman numeral 6 was 4.5. So that comes out to be 3.68294,197. And finally, Roman numeral 10 And I think this one here, you do P of 5 minus P of 4.99 4/9. And your calculator also, at least mine anyway, did give me 4. So what's really happening? Well, the closer you get to the value of t equals -5, or t equals 5, as t gets very close to 5, we're finding that the average rate of change is getting closer and closer to 4. And that is the solution to this one.